Hey guys, welcome back to AlgoYogi. We are now doing stack series. Our next problem in the list is Asteroid Collision. Let's go to LeetCode. Okay, it's taking a little time. We are given an array of asteroids of integers representing asteroids in a row. The indices of the asteroid in the array represent their relative position in space. For each asteroid, the absolute value represents its size, and the sign, positive or negative, basically represents its direction. Positive meaning it's moving towards right, and negative meaning it's moving towards left. Each asteroid moves at the same speed. Find out the state of asteroids after all the collisions. Moving in opposite direction, they will definitely collide. What should be the state? Let's read it out. If two asteroids meet, collide, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction, same speed, they will never meet, they will never collide. So the problem is super straightforward. I guess these three sentences definitely explain the problem really well, and it seems so easy honestly, but actually it's just a little tricky when you start to write down the condition, the code. You have to take care of a little bit of edge cases. So let's see how we are going to approach it. So we have already studied that positive means it's going towards right, all right, and negative means it's going towards left, right? Now if you see asteroids in the first example, right over here we have three asteroids, and this is the relative order. Now the reason I'm drawing this two direction arrow is because this one is moving to right, this one is moving to right with the same speed, but -5 is moving to this side. So how do we actually calculate basically the final state? So one of the way, the brute force way would be, how about we just go through our asteroids and see the two asteroids which have neighboring asteroids which have opposite direction. They're going in opposite direction. So basically these two are going in opposite direction. Then I will check, okay, which one is greater absolute value. So ABS -5 is smaller than 10, all right, ABS 10 or whatsoever. Then what happens? This one gets destroyed. What is the state? This is the state. Since these are both positive, they will keep moving in the right direction and they will never meet. So this will be the final state. This is what we return. But sometimes it might happen that this -5 was going like this direction, let's say. Then also it will keep going to left, and this is what we return in the end. Now I think in one of the approach where you are only dealing with two asteroids, it's gonna be of really complex time complexity, big time complexity, but we can bring it down to big of n by using stack data structure, since stack will help us track the asteroids which are moving in right direction. We can keep appending them, but whenever we come across any left direction asteroids, we start popping from stack if my left going asteroid has a greater absolute value. Otherwise you basically just ignore it, or you append it if stack was empty. Now if stack was empty, then you basically push it in. All right, so what do we do now? So let's draw a beautiful stack right here that will that does not look like a stack. Anyway, yes, we're gonna draw a stack like this. Then we're gonna go over our asteroids from left to right, and these are the conditions that we will be checking. So we'll go over all the asteroids. So let's say for A in asteroids, if there are two conditions. If either A is less than 0, that means this condition, left condition, my asteroid is going to left. If it is going to left, there are basically, first thing is either my stack is empty. If my stack is empty, that means I will append that to my stack, right? That to my stack, or my stack has some values. And then I will basically push them in, right? But let's say these are the conditions that we will have. Else would be like right here. Else would be you just append to your stack. So this is my stack. I will, if something is going in positive direction, then I will push to my stack. That's what I'm like going with. But whenever you see a negative asteroid which is coming in the left direction, so you can say this is how negative values will come and this is how positive values will go up. So that will help us basically get the direction of these asteroids. Otherwise, if these are positive, I'm just appending them to my stack like this. So A. So what must have happened is, when I see a positive value, I saw 5, so I'll push it to my stack. Then I saw 10, so I'll push it to my stack. But when I'm seeing negative 5, so what I want to do is I want to check if my stack has something, because now this asteroid is coming in opposite direction and I already have some on my stack, some asteroids. So what I'll do is I will run a loop while stack and stack top is greater than 0. Let's say greater than 0. Okay, I think maybe I should write it like a little nicely. This is greater than 0. So what does that mean? That means I'm seeing a positive value on the top of my stack. There is a positive value. If there is a positive value, what I want to do is, there will be three cases. If my current A, which is negative, so I'm going to take an absolute value of this. This is greater than top. I'm going to call it top of my stack. This is my top, by the way. So if this is the case, that means I'll pop the value from stack dot pop. All right. If they are both basically, if this absolute value is smaller than top, if this is smaller than top, that means I will break. Why I will break? In this case, it is small. I will just break out of this loop, and now I don't have to append it because this value is greater than negative 5 in terms of absolute value. I mean, I don't mean just like positive or negative. It's just the absolute value. 10 is greater than 5. So that means 10 must have destroyed this. 10 just destroyed this case. So if 10 destroyed it, we come out of this loop, and then basically our iteration is over on asteroids, and we will return basically this state. This present state will be my answer. This is my answer. But there is one more case I want to write. Else, let's say this was, instead of negative 5, let's say this was negative 10. If this was negative 10, that means they're both equal. That means both of them get destroyed. So else both of them get destroyed. So what I'll do is stack dot pop, and I will break here, right? Because both of them got destroyed. Otherwise, if let's say this was negative 15, that means this will destroy this 10. This is the condition that will pass in this case. this is the condition that will pass in this case, stack.pop, and it will keep looping until either stack is empty or stack -1 is basically negative, right? This is not greater than 0, so this is not negative. Either you find a negative value on the stack, or you basically destroy all the asteroids which were going in right direction in this stack, and then and finally we will keep a flag to basically decide. Flag is needed just to have like these conditions written nicely. Otherwise, like, we can avoid flag also. If you just have, you can bring out the while over here and just have the append in the end. But I think having that flag will make things nice for us. We'll have a flag to track that we need to append that asteroid in the end. Let's say if this was -15, that means this was the only condition where this -15 didn't get destroyed. So we will have some, like, let's say survived flag. You will see when we write the code, and if survive, initially we'll have it true, and these two places will mark this false, right here and right here, because in these two cases it gets destroyed. But if this comes out to be true here, if this survived is true, we'll append this value to my stack. So it must have destroyed these two, and then we'll add it to our stack, and that will be my final solution. All right, so I think things are pretty clear right now. So we're gonna go ahead and implement this pseudocode, and this will work. Okay, it will be of big of n time complexity, and it will be of big of n space complexity, time and space, since there might be a case where they are all going in one direction. So that will be the space used by my stack, and I'm going through n asteroids. All right, so this was quite easy, I guess. Only writing in code and considering those edge cases is the tricky parts, but I think that went well here. I'm going to now write. Looks pretty good. So we'll have a stack empty in the beginning, then we will have basically a for loop for a in asteroids, okay, I made a mistake. I don't want to, yes, for asteroids. So there are two cases. If a is lesser than 0 or a is greater than 0, there are two cases. Else case would be this. In else, we just stack.append because it's going up. Either we will come across some negative value which are basically going this way, but if it is going to right, then I will just keep appending to my stack. I think that's what we understood in the conceptual part. Or we are seeing a negative value integer, which means it's going towards left. So whatever we are pushing to our stack, it's going towards stack, and maybe just want to destroy those asteroids. So what we do is we will have a while loop, because this value could be bigger and destroy multiple asteroids. So while stack and stack top is greater than 0, that means top of the stack asteroid is going up, or you can just say like right, if you imagine the stack opening towards basically going from left to right. So in these two cases, I want to check if my stack's top, which will be positive in this case, is greater than, or let's say it's yeah, so it's smaller than, let's say top is smaller than my asteroids, but I'm gonna check for the absolute value of a. If this is the case, that means this negative integer, its absolute value is greater than on top of the stack, which was positive. So that means this negative is going to destroy it. So I'll just do stack.pop. I do stack.pop, and then it will again loop, and there might be more asteroids it's gonna destroy it. So then there is another condition where this value is smaller, so top of the stack is greater, so this will get destroyed, and I want to break out of this loop. I don't want to append this value because this just got destroyed. Last case is both are equal. In that case, stack will be popped, the top value, because it's gonna get destroyed when both asteroids are equal, but one negative, one positive, both get destroyed. And I will break out of this loop. And just remember, if you remember, there was just little condition that we talked about. What if this asteroid actually was going in negative direction and stack was empty? Either stack was empty or it just destroyed all of the asteroids going in right direction. That means we will be pushing it to my stack. So how do we know? We'll have a flag to keep a track of that. So let's have a flag called survived. Initially it's going to be true. We're considering that it survived, but what we can do is, what are the cases it didn't survive? I think these are the cases it didn't survive. Either stack's top was bigger, that means it destroyed it, so it didn't survive. I'm gonna call it false. And then when both were destroyed, then also this will be destroyed. So these are the two cases where this asteroid didn't survive. But if I come out of this while loop, then I will check if survived, then I will append it to my stacks. Okay, append to my stack. I'll just append it. All right, so now I think this is all good. Let's test it. I'm gonna finally return the final state, which will be stack, and that's it. I'm gonna zoom out. Code is right there, nice and clear. If negative, if positive, we are appending, we are destroying based on these conditions. Let's run it. All right, I'm gonna submit it. Awesome. Let's write down the time complexity. We already talked about it. Time complexity is going to be big of n. N is the number of number of asteroids. Stocks. I didn't trade anything today. Space complexity would be big of n as well. Awesome. Now this is the thing where we could actually do this. I think instead of this if here, what I could do is I could just always append a if I were to take it out into basically, let's try this, because this condition I could just get rid of. So let's get rid of survived, and these two, while a is, let's take it out and put it in our while loop, and let's just call it and then I'm gonna get rid of this. I'm just trying this thing. I'm trying to because it felt like that we didn't need this survived flag, and the reason is I think I will append anyway this a if this was basically coming out of this while loop, if it survived this while loop, right? If it survived, and we can put this thing either while happens or else either this is getting executed, this is getting executed, or if it doesn't, then this gets executed, right? So I think this should work. Let's try it out. Let's try it out. Yes, it does. Awesome. And the reason is there must be one condition where this will fail. Either you have basically you're breaking out of this, or this is smaller than 0 and stack is not empty, or it's greater than 0, then we have to append it, or stack is empty, then we have to append it, or this stack stop is positive, and then it basically either got destroyed, it got popped, and I think in all the cases, like if it is coming out, we are basically adding it to our stack. I think that's the logic here. But our own code with the flag is still perfectly valid. It's just like this is a less number of lines of code. So let's go to AlgoYogi and mark this solved, and see you guys later. Bye bye.